What if I told you that the story of civilization might not have begun here on Earth at all? That the red planet we've spent centuries treating as nothing more than a barren wasteland may once have carried the weight of cities, cultures, and people long before the first human walked upright. Mars, dry and lifeless today, could have been the cradle of something far older than us. It may look like a dusty desert in the sky, but the truth could be that our history is only a continuation of a much older timeline, one that started under a red sky. And here's why this matters. If Mars once hosted thriving civilizations and we ignore the possibility, we risk missing the real story of who we are. Our identity, our origins, even the definition of what it means to be human could be built on a false assumption that Earth was the beginning. What if it wasn't? What if intelligent life had already risen, struggled, and fallen before we ever existed, leaving us not as pioneers but as heirs to a forgotten legacy? The implications are huge. It means humanity's story doesn't start in Africa or in our first villages. It stretches back billions of years to another world. To dismiss that possibility is to misunderstand not only where we come from, but also the true age of intelligence in the universe. When we look at the night sky, most of the stars look the same, tiny twinkling points of light. But there's one that has always stood out, one that shines with a reddish glow, a light so different it couldn't help but draw the attention of every ancient culture that ever looked up. That wandering red star was Mars. And for thousands of years, it wasn't just a planet. It was a symbol, a warning, and sometimes a god. The Babylonians were among the first to record it seriously. They tracked the movements of the bright red wanderer and connected it to their god of battle, Nergal. To them, Mars wasn't just another point of light. It was a cosmic sign of bloodshed, war, and destruction. They gave it a role in their myths because its strange red shine suggested danger. In a world where the heavens were believed to shape human fate, Mars was the planet of conflict. The Romans took that idea and made it even bigger. For them, Mars became Mars, the god of war, a figure of power and conquest, so important that the very month of March, the time when armies traditionally began their campaigns, was named after him. Whenever the Romans looked at that fiery point in the sky, they weren't just seeing light reflected from the sun. They believed they were looking into the eyes of their god, a reminder of war's necessity and its consequences. Even in peace, Mars stood as a reminder that violence was always waiting just beyond the horizon. But Mars wasn't only seen as a god of destruction. To the Egyptians, its unique red glow connected it with Horus the Red, a representation of the balance between life and death. In cultures from India to Mesoamerica, Mars was cataloged, mythologized, and feared. Always red, always ominous, always separate from the other lights of the heavens, and for good reason. When you see Mars in the night sky without any telescope, it does look unsettling. It doesn't twinkle like the stars. It's a steady blood-colored dot, hanging there as if it's watching you back. Ancient people weren't wrong to think it was different. They just didn't know how right they might have been. As centuries passed and technology advanced, Mars became more than just myth. When telescopes were invented in the 1600s, the red planet was suddenly no longer just a glowing dot. Early astronomers could make out surface features, faint changes in light and shadow, polar caps that seemed to grow and shrink with the seasons. For the first time, people realized that Mars was not just another star but a world, a place with geography, a place that changed over time. That realization was a turning point. If Mars had polar caps like Earth, then maybe it had weather. If it had dark regions that shifted, maybe it had vegetation. By the 19th century, astronomers like Giovanni Schiaparelli reported seeing canali, channels that seemed to stretch across the Martian surface. The word canali was mistranslated into English as canals, and that mistranslation set fire to the human imagination. Suddenly, people weren't just seeing random markings. They were seeing engineering, structures, evidence of intelligence, and the idea took hold. The famous American astronomer Percival Lowell built entire observatories to study these supposed canals. He published detailed maps, connecting them into vast networks, suggesting they were the work of a dying civilization desperately trying to transport water from the poles to the equator. In Lowell's mind, Mars was not a barren world. It was a planet in crisis with intelligent beings struggling to survive as their environment collapsed. His theories captivated the public. Newspapers published his maps. Writers like H.G. Wells drew inspiration from his ideas. leading to stories like the War of the Worlds, where Martians invade Earth not out of malice, but out of necessity. They were refugees from a dying planet. For ordinary people at the time, this was terrifying and thrilling. If civilizations existed on Mars, then humanity was no longer alone. But the darker twist was clear. If they were dying, if their planet was turning to dust, then maybe ours could too. Mars became both a mirror of hope and a warning of collapse. Of course, with time and better telescopes, the canals faded into disappointment. What Lowell thought were massive waterways turned out to be optical illusions, tricks of the eye created by poor resolution and wishful thinking. But the damage, or perhaps the inspiration, had already been done. Mars had cemented itself in our imagination as the most likely place for life beyond Earth. Even when the canals disappeared, the idea of Martians did not. And maybe that's because deep down, we've always known there was something strange about Mars. Think about it, out of all the planets in our solar system, only two have truly fascinated humanity for centuries: Venus and Mars. Venus is shrouded in thick clouds, forever hiding her secrets. But Mars? Mars shows its face openly. Its surface, its polar caps, its scars, all of it visible, almost taunting us. Unlike Jupiter or Saturn, which are gas giants too alien to compare to Earth, Mars looks familiar. It's close in size, it has seasons, it once had rivers and lakes. It is just similar enough to remind us of home, but just different enough to feel eerie. That eerie familiarity is what turned Mars into the prime candidate for life. If there were civilizations beyond Earth, Mars seemed the obvious choice. Myths gave it a soul, telescopes gave it geography, and imagination gave it people. Even when the canals proved false, we couldn't let go of the thought. Because Mars raises questions that cut deeper than science. What if life is not unique? What if civilization is not unique? What if we are just the most recent chapter in a much older story? The fascination with Mars, from gods of war to maps of canals, was never just about the planet itself. It was about us. We looked at that red light and saw our fears, our violence, our potential futures. We projected gods onto it, then civilizations, then extinction. Mars has always been a mirror. In ancient times, it reflected the brutality of war. In the modern era, it reflected the fragility of survival. And today it reflects the possibility that we may not be the first intelligent beings to walk under a sky and wonder about the stars. That's the dark twist in this story. Mars isn't just another planet. It's the one world that has always forced us to confront our biggest questions. Are we alone? Are we safe? Are we really the first? Ancient cultures may have answered with myths. 19th century astronomers answered with canals. Today we answer with rovers and data. But the questions are the same, and they haven't gone away. And maybe, just maybe, they never will. Because if Mars truly did once harbor civilizations before Earth, then all of human history is not the story of a beginning. It's the story of a continuation. A torch passed from one world to another, and we're only just starting to realize it. When you look at Mars today, it's easy to dismiss it as nothing more than a cold desert, a world of dust storms, craters, and lifeless rock. But if you could peel back the layers of time, the story changes. The surface of Mars isn't just random terrain. It's a record book carved in stone, one that tells us about rivers that once flowed, lakes that once shimmered, and maybe even oceans that once stretched across its northern plains. And if all that is true, then Mars was once more Earth-like than we ever imagined. The evidence starts with valleys. If you've ever flown over a river system on Earth, you've seen how streams carve winding paths through the land. Now, when spacecraft orbit Mars, they see the same thing. Long valleys branching like tree roots, converging into basins, and splitting again into smaller channels. These aren't cracks or random scars. They follow the same patterns water makes as it flows downhill. Some of them stretch for hundreds of miles, winding through craters and across plains, as if rivers once ran for ages before vanishing into dust. Then there are the deltas. On Earth, deltas form where rivers slow down and spread into larger bodies of water, dropping their sediments into fans and branching shapes. Mars has them too. Jezero Crater, the landing site of NASA's Perseverance rover, has one of the clearest examples, a fossilized delta preserved in stone. Its channels, fans, and layers look strikingly like the ones we know from Earth's river mouths. It's not just a similarity. It's géological déjà vu, the kind that says water was once here in large amounts, moving across the land for long stretches of time, moving across the land for long stretches of time. And it wasn't just rivers and deltas. Mars also holds basins, low-lying regions that could once have been lakes. Some show signs of ancient shorelines, curved edges where waves might have lapped for centuries. But the most dramatic possibility lies further north, in the vast lowlands that cover almost a third of the planet. Many scientists believe this region was once filled by an ocean. Satellite images show sweeping arcs that resemble coastlines, boundaries that could have marked the edge of seas so large they rivaled Earth's Arctic Ocean. Imagine it, a northern Mars covered in rolling waves, while rivers carried fresh water into its depths. If true, this changes everything. Oceans don't just appear briefly. They require stability, a thick atmosphere to hold in heat, a climate that allows liquid water to remain, and time, millions of years, maybe longer, for that water to shape the land. An ocean on Mars would mean that this planet wasn't just touched by habitability. It lived it. It had a period where conditions were not only friendly to life but demanding of it. So what happened? How did Mars go from a world of rivers and seas to the barren desert we see today? The answer lies in its invisible shield, or rather the loss of it. Billions of years ago, Mars, like Earth, had a magnetic field. That magnetic field was generated by movement in its molten core, and it served as a protective bubble. On Earth, our magnetic field deflects the solar wind, a constant stream of charged particles blasting from the sun. Without that protection, the solar wind would strip our atmosphere away, atom by atom. For a time, Mars had that shield. It allowed the planet to hold on to a thick atmosphere, one capable of trapping warmth and keeping water liquid on the surface. But at some point, perhaps around 4 billion years ago, that shield collapsed. The core cooled, the magnetic field disappeared, and the solar wind began to tear into the atmosphere. Slowly, invisibly, Mars started to lose the very air that made it habitable. Once the atmosphere thinned, the oceans couldn't last. Water either evaporated into space or froze underground. The rivers dried, the lakes shrank, and the northern seas retreated until nothing was left but dry channels and dusty shorelines. What had been a blue planet became red, stripped of the very conditions that made it Earth-like. This is where the story turns dark. Because Mars isn't just a tale of a dead world, it's a warning. Here was a planet that had everything it needed: water, air, time. For millions of years it was stable, and yet it couldn't hold on. The loss of its shield meant the loss of its future. No matter what life might have begun there, the collapse of the magnetic field ensured it would struggle, if not vanish entirely. When scientists study the geology of Mars, they're not just looking at rocks. They're looking at memory. Those valleys, deltas, and basins are scars of a world that once lived and then died. Each one is a fossil not of organisms but of conditions. A planet that was once alive with rivers and weather, now frozen in time. And here's the unsettling part. Earth is not invincible. Our planet's magnetic field still protects us, but it too is generated by a dynamic core. What happened to Mars reminds us that habitability isn't permanent. It can be lost. Mars is the planetary version of a ghost, showing us what happens when a world's defenses fail. But it's also why Mars fascinates us so deeply. Unlike Venus, which hides its surface beneath toxic clouds, Mars reveals everything openly. Its dried rivers are visible from orbit. Its canyons stretch across entire continents. Olympus Mons, the tallest volcano in the solar system, looms like a frozen reminder of past energy. Valles Marineris, a canyon so vast it dwarfs the Grand Canyon, shows where floods and tectonics tore the land apart. It's all there, waiting to be read like chapters of a book, and every chapter points to the same conclusion. Mars was once a world in motion, shaped by water, wind, and fire. Much like Earth, the dramatic irony is that we are studying Mars at its weakest moment, long after its prime. Imagine if someone studied Earth not now, with forests and oceans, but billions of years in the future, when our own seas might be gone. That's what we're doing with Mars. We're piecing together fragments of a planet that once might have been vibrant, but that time erased. And that's why these geological signs are more than just science. They're part of a haunting narrative. Mars isn't just another rock in space, it's a fallen world, a place that once might have had rivers teeming with life only to be stripped bare, a planet that began so similar to ours but ended so differently. And if we want to understand our own future, we have to pay attention, because Mars isn't just telling us what it lost, it's warning us what we could lose too. If you step outside on Earth and take a deep breath, you probably don't think twice about it. Air is everywhere. So normal that we forget it's the single most important thing keeping us alive. Now imagine standing on Mars and trying the same thing. You'd be dead in seconds. The air there is so thin, less than 1% of Earth's, that it can't hold heat, can't shield you from radiation, and can't keep water liquid on the surface. But here's the part that often gets overlooked. It wasn't always this way. Mars once had an atmosphere thick enough to wrap the planet in warmth, keep rivers flowing, and maybe even sustain entire oceans. So the real mystery isn't why Mars is lifeless now. It's how it lost the very shield that once made it alive. The culprit is the solar wind. Think of the sun not as a peaceful glowing ball in the sky, but as a constant storm. It spits out streams of charged particles, protons and electrons, that race through space at incredible speeds. On Earth, our magnetic field acts like a giant invisible umbrella, deflecting most of this deadly radiation and keeping our atmosphere safe. But Mars lost its umbrella. Billions of years ago, its molten core cooled, its magnetic field collapsed, and the solar wind was free to attack. From that point on, the sun began stripping Mars bare atom by atom. It's almost impossible to imagine, but this process literally blew the air away. The solar wind collided with the upper atmosphere, knocking molecules into space. Over millions of years, what had once been a thick blanket of carbon dioxide, nitrogen, and water vapor was reduced to a whisper. Mars went from a world of blue skies and clouds to one where the air is so thin you couldn't even hear thunder. Every breath of atmosphere was stolen by the sun. This isn't just speculation, we've seen it happen. In 2014, NASA launched the MAVEN mission, Mars Atmosphere and Volatile Evolution. Its job was to study exactly how Mars's atmosphere continues to escape today. What it found confirmed the nightmare. Even now, with Mars long since dried up, gases are still leaking into space, carried off by the solar wind. MAVEN measured streams of oxygen and carbon dioxide drifting away, proving that Mars is still being eroded piece by piece every single day. It's a slow death, but it never stopped. The consequences of this atmospheric collapse were catastrophic. Without a thick atmosphere, the surface temperature dropped. Without pressure, liquid water couldn't survive. It boiled away or froze instantly. The rivers that once carved valleys vanished. The lakes evaporated, leaving only cracked basins behind. The northern ocean retreated, perhaps into the soil, perhaps lost forever to space. Slowly but surely, Mars turned from a world of water to a world of dust. This is where the story takes a darker turn. Because the vanishing of Mars's atmosphere wasn't sudden, it was a long decline. Imagine being there as it happened. At first, the skies might still have been blue, the lakes still full. But with each generation, the air grew thinner. Winds grew colder. Water retreated underground. If life existed, it would have watched its world collapse in slow motion, powerless to stop it. Entire ecosystems could have withered. Civilizations, if they existed, might have fought for survival against an enemy they couldn't even see, the invisible theft of their air. And this is what makes Mars terrifying. It shows us that habitability isn't guaranteed. Earth feels stable because our atmosphere has lasted billions of years. But Mars proves that a planet can lose everything. The sun, which gives life, can also take it away. All it takes is the failure of a magnetic shield, and a world that once looked like paradise becomes a wasteland. When you look at Mars today, the endless dunes, the frozen poles, the sky tinted red, it's hard to picture it as anything else. But that's only because we're seeing the aftermath, not the history. The valleys, the deltas, the basins, they all whisper the same truth. Mars was once alive with air. It had clouds, rain, maybe even storms that rolled across oceans. Then over billions of years, it suffocated. NASA's MAVEN mission gave us more than numbers. It gave us perspective. By measuring how much atmosphere still escapes today, scientists could estimate how much has been lost. The results are staggering. Mars may have once had an atmosphere as thick as Earth's, enough to support a greenhouse effect that kept the planet warm for hundreds of millions of years. But now, what's left is barely a trace, a faint veil of carbon dioxide too weak to do anything, and that's the haunting part. Mars didn't fail because it lacked the right ingredients. It had them all: water, chemistry, energy, and air. It failed because it couldn't hold on to them. Its shield dropped, its atmosphere bled away, and everything else followed. Its atmosphere bled away, and everything else followed. So the next time you see a photo of Mars, red, barren, empty, remember that it wasn't always so. It was stripped down, reduced, and left exposed. A world that once might have been green and blue, silenced into rust and rock. And in that silence is a warning for us. Earth's magnetic field protects us now, but what if one day it doesn't? Mars is proof that planets can die, even when they start with everything they need. That's why the vanishing atmosphere isn't just a detail in planetary science. It's the key to understanding why Mars changed. It wasn't always lifeless. It became lifeless. And in that transformation, Mars gives us a mirror of fragility, a reminder that the difference between a living planet and a dead one can be as simple as the loss of air. If you want to know whether a planet could ever support life, you don't have to guess. There are 3 keys that scientists always look for: water, energy, and chemistry. Put them together, and you have the recipe for biology. Leave one out and life has no foundation. That's why Mars has never stopped haunting us. Because for a long stretch of its history, it seems to have checked every box. Let's start with water. On Earth, every form of life we know depends on it. Our cells are built in it, our chemistry runs on it, and without it, nothing survives. Now, when we look at Mars, the evidence for water in the past is everywhere. Ancient valleys carved into the land, deltas where rivers once emptied into lakes, basins shaped by shorelines. Even today, polar caps of ice grow and shrink with the seasons. Beneath the surface, radar hints at buried glaciers, maybe even salty underground lakes. Water didn't just touch Mars briefly, it shaped it, and in some places it might still be waiting. Next comes energy. Life doesn't just need to exist, it needs to run. On Earth, plants and microbes take energy from sunlight, while deep-sea creatures live entirely on chemical reactions at volcanic vents. Mars, in its early days, had both possibilities. Sunlight streamed through a thicker atmosphere, and volcanic activity pumped heat and minerals into the crust. Hydrothermal systems, those same mineral-rich hot springs that gave rise to life on Earth, may have bubbled under Martian soil. If you were a microbe back then, Mars might have looked like paradise. The third key is chemistry, and here's where it gets even more intriguing. Mars's surface rocks contain many of the same essential elements life uses here: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. These aren't exotic ingredients. They're the building blocks of DNA, proteins, and cells. And thanks to rovers like Curiosity, we know that organic molecules, complex carbon-based compounds, are preserved in Martian rocks. They don't prove life existed, but they prove the ingredients were there. Mars had the pantry stocked, the stove burning, and the water boiling. All it needed was the spark. Put all of this together and Mars stops looking like a dead desert and starts looking like a world that could have been alive. For a long stretch of its history, it wasn't just habitable in theory, it was habitable in practice. Billions of years ago, it had rivers, volcanic vents, and chemical richness. If life on Earth managed to emerge under the same conditions, why wouldn't it have happened there too? That's the part that makes scientists lean forward in their chairs. Because life on Earth appeared remarkably fast. Within a billion years of the planet cooling, the first microbes were already here. It didn't take long, which suggests that once the recipe is in place, life may not be rare. It may be inevitable. If that's true, then Mars almost certainly had its shot. It could have hosted microbes in river deltas, colonies around hot springs, or even communities deep underground, shielded from radiation and cold. And here's the eerie part. Some of those microbes could still be there, even though the surface of Mars is hostile now, bathed in radiation, frozen and bone dry. The underground might tell a different story. Beneath the soil, where water can stay liquid and volcanic heat might still seep, microbial life could cling to existence, tiny invisible survivors of a world that once thrived, waiting for us to find them. But here comes the darker twist. Because if Mars once had everything it needed for life and life still disappeared, what does that say about us? The 3 keys don't guarantee survival forever. Mars proves that a planet can start with all the right conditions and still lose them. Its water went underground. Its energy waned. Its chemistry stayed locked in rocks. If life began there, it may have been wiped out before it had a chance to grow beyond microbes. A planet full of potential, silenced before it reached its peak. And that's what makes this question so unsettling. Mars isn't alien in the sense of being completely different from us. It's alien in the sense of being familiar, too familiar. Its valleys look like ours. Its rocks hold the same chemistry as ours. Its past is Earth's mirror, and yet one lost its way while the other flourished. The difference wasn't in the recipe, it was in the outcome. So when we look for signs of past life on Mars, we're not just searching for microbes. We're searching for answers about ourselves. Were we lucky or are we just next? If Mars had the 3 keys and still fell silent, then maybe habitability is fragile, and even Earth's stability won't last forever. The search goes on because the stakes are more than curiosity. Every rover that digs into Martian soil, every instrument that scans for organics is really asking a bigger question. Is life a cosmic accident or a cosmic rule? Mars is our best chance to find out, because it's the one world that started with the same ingredients and then took a different path. If we find that life sparked there too, even if it was only microbial, then we'll know the universe may be teeming with biology. But if we find nothing, then maybe Mars tells us something darker, that life is rarer and more fragile than we want to believe. Either way, Mars forces us to confront the truth. It wasn't always dead. It was once alive with possibility. Water flowed, energy burned, chemistry thrived, and then piece by piece it slipped away. Which means the red planet we see today isn't just a world lost to time, it's a warning written in stone. When people think about life on Mars, the picture is usually small. Tiny microbes clinging to survival under rocks or buried deep underground. That's the safe guess, the version science is most comfortable with. But here's a question worth asking. What if life there didn't stop at microbes? After all, Earth didn't. Earth started small too, but given enough time, microbes evolved into forests, oceans full of creatures, and eventually civilizations. And here's the thing, Mars had almost the same amount of time to work with. So why should we assume it never got further? On Earth, the story of life is one of escalation. For billions of years, the planet was ruled by microbes. They were invisible, single-celled, and tough enough to survive almost anything. But eventually, some of them joined forces. Cells began working together, forming more complex organisms. That's when things started to change. Over time, complexity gave rise to plants, animals, ecosystems, and finally the ancestors of humans. From pond scum to pyramids, the leap is enormous, but it happened because life had the time and the conditions to experiment. Now, think about Mars. In its first billion years, it was warm, wet, and chemically rich. It had water flowing across the surface. It had volcanic heat underground. It had all the same raw ingredients that Earth used to climb its evolutionary ladder. That's not speculation, that's geology, which raises the uncomfortable possibility. If evolution isn't a miracle but a process, then Mars had every chance to follow the same script. Imagine what that might mean. Mars with not just microbes, but with seas filled with algae, fish-like creatures or something stranger, adapted to weaker sunlight and thinner skies. Imagine forests of hardy plants stretching across its valleys, oxygenating the atmosphere. And if time truly allowed, imagine beings with the intelligence to shape tools, build shelters, and create culture, long before Earth was even stable enough to support human ancestors. It sounds like science fiction, but the timeline makes it at least worth asking. Mars may have had hundreds of millions of years of habitability. On Earth, that was enough time to go from microbes to multicellular life. The window was there. The conditions were there. The question is, did Mars take that next step? Or was it cut short before complexity could get a foothold? The challenge is evidence, or rather the lack of it. Mars today is a harsh world, and its surface has been battered by radiation and dust storms for billions of years. Even if larger organisms once existed, their remains may have been erased, ground to dust, or buried deep beneath the surface. On Earth, fossils survive because they get preserved in layers of sediment and shielded from erosion. On Mars, with less protection, most traces could vanish long before we arrive to look. But absence of evidence doesn't necessarily mean absence of life. From orbit, Mars already shows us familiar patterns: riverbeds, shorelines, deltas that look uncannily like Earth's. If the landscape can trick us into thinking we're looking at Earth's features, maybe its biology once followed the same familiar rules. Maybe the only reason we haven't seen it yet is because we're looking in the wrong places, or with tools too limited to catch the faint signs that remain. Here's the darker twist. If Mars did host complex life, even for a short while, then its silence now becomes even more chilling. Because it would mean not just that Mars was habitable, but that it was once inhabited, rich, alive, and then stripped bare. An entire biosphere might have flourished, only to vanish as the atmosphere thinned and the oceans dried. If civilizations ever rose there, they could have collapsed before Earth's story even began. In that case, humanity wouldn't be the first intelligent species of the solar system. We'd just be the first still standing. And what does that mean for us? It means survival isn't guaranteed, no matter how advanced life becomes. Mars may have once held forests, seas, or even intelligent beings, and yet here we are, staring at a desert. The planet is a tombstone of possibility, a reminder that intelligence doesn't always save a species from extinction when the planet itself turns against you. So the question, did life evolve beyond microbes on Mars? Isn't just curiosity, it's a mirror. If it did, then Mars shows us what happens when even complex ecosystems collapse. And if it didn't, if it stayed microbial until the end, then maybe complexity is rarer than we think, and we should count ourselves lucky to have beaten the odds. Either answer is sobering. That's why Mars refuses to leave our imagination. It isn't just about finding bacteria in a rock. It's about asking whether life there ever took the same daring steps Earth did, and what its fate says about ours. Because if Mars once had forests, seas, or civilizations, then its ruins are a warning. Survival can be temporary, and no world, no matter how alive, is safe forever. When we picture civilizations, we usually imagine them like ours: villages along rivers, cities built under open skies, towers reaching upward. But what if civilization first took root not on Earth but on Mars? It wouldn't have looked anything like ours. The conditions there would have forced its people to build differently, live differently, and maybe even think differently. If Mars ever had civilizations, their world would have shaped them in ways we can only begin to imagine. Let's start with the air, or the lack of it. Even in its best days, Mars never had an atmosphere as thick as Earth's. Breathing there would have always been a challenge. So if civilizations arose, open-air cities might not have been possible. Instead, they would have built downward, carving shelters into the ground where air could be trapped, recycled, and protected. Underground chambers, sprawling cave networks, or even cities beneath ancient lava tubes could have been the Martian version of skyscrapers. Not rising into the sky, but burrowing into stone to survive. Then there's the cold. Mars receives less sunlight than Earth, and without a strong atmosphere, heat escapes quickly. For survival, civilizations would have had to master warmth. On Earth, we used fire, wood, and eventually fossil fuels. Mars might have leaned on something else: geothermal energy. The planet's massive volcanoes tell us that heat once surged beneath its surface. Civilizations could have tapped into that underground warmth, channeling it into their shelters, using it to power machines or heat water. A culture built around geothermal springs isn't fantasy. It's a logical survival strategy. And then comes the most precious resource of all: water. Mars's rivers dried up long ago, but while they lasted, civilizations would have had to control every drop. Agriculture could never have been sprawling fields under the sun. Instead, it would have been carefully managed. Crops grown in volcanic soil rich with minerals, irrigated by channels carved from underground ice or reservoirs of melted glaciers. Recycling water would have been more than a convenience. It would have been the foundation of survival. Every drop counted. Every loss could have been fatal. It's not impossible to imagine farms beneath the surface, lit by redirected sunlight or fueled by geothermal lamps. Underground greenhouses, hydroponic systems, and fungal cultivation could have sustained whole communities. Martian agriculture might not have looked like rows of wheat, but like cavern forests of moss, fungi, or plants adapted to low light and cold. A society built not on abundance, but on resilience. Dust storms would have added another layer of challenge. Mars is infamous for storms that can blanket the entire planet, choking sunlight for weeks at a time. Above-ground settlements would have been dangerous. Machinery could jam, power systems could fail, and crops depending on sunlight could starve. So again, survival points underground. A Martian civilization might have lived their entire existence sheltered from the surface, venturing out only when storms cleared, treating the open sky not as home, but as hazard. What kind of culture grows from that kind of life? A people who measure time not by seasons but by the intervals between dust storms. A society that prizes cooperation, because every individual's survival depends on how well the group manages water, heat, and air. A worldview shaped not by abundance but by scarcity, where Earth civilizations told myths of harvest and rain. Martian civilizations might have told myths of shelter and warmth, gods of underground fire instead of open skies. And yet, this picture of survival isn't just speculation. It's consistent with what we know about Mars. Lava tubes wide enough to fit skyscrapers already exist. Minerals in the soil are rich enough to grow plants if given water. Subsurface ice has been confirmed. The raw materials for survival are there. If civilizations ever arose, they would have had to use them. But here's where the story turns darker. Because no matter how clever a civilization might be, they were still fighting a losing battle. Mars's atmosphere wasn't just thin, it was vanishing. With every passing generation, the air outside grew colder, drier, and deadlier. Even the best underground shelters couldn't change the fact that the world above was dying. Imagine living in a society that knew its planet was slipping away. Each year a little harder than the last. Each century with fewer resources to spare. Civilizations might have fought over dwindling water, struggled to adapt crops to harsher conditions, or simply dwindled as survival became too difficult. And what if they succeeded? For a time. Imagine a civilization holding on underground for thousands, maybe millions of years, their culture built entirely on endurance. And then slowly, even that endurance wasn't enough. The ice retreated too far. The heat faded too deeply. The storms grew too long. A world that once supported communities was stripped until nothing remained but dust. That's the unsettling thought. If Mars once had civilizations, they didn't collapse because of war or conquest. They collapsed because their planet betrayed them. No amount of technology, ingenuity, or cooperation could save them from the slow suffocation of a vanishing atmosphere. The open skies became impossible. The rivers became memory, and eventually even the underground shelters fell silent. And if that happened, then Mars today isn't just an empty world. It's a graveyard of civilizations erased by time. Their farms, their tools, their stories, all buried under dust or ground away by storms. We may never see them, not because they never existed, but because the planet itself wiped them clean. That's why the idea of Martian civilizations is both exciting and terrifying. It forces us to ask not only whether life could survive there, but whether survival is ever permanent. Mars shows us that even a thriving world with intelligent beings might not last forever. And if they couldn't, what makes us so sure we can? When humans look at strange shapes in nature, we can't help ourselves. We see patterns. A cloud becomes a dragon, a rock becomes a face, a shadow on a mountain becomes a pyramid. Our brains are wired to find meaning even when it isn't there. And nowhere has that tendency caused more debate than on Mars. Because for decades, the red planet has been sending back images that make us wonder, are we just seeing rocks? Or are we staring at the ruins of a forgotten civilization? The most famous example came in 1976, when NASA's Viking 1 orbiter photographed a region of Mars called Cydonia. At first glance, the picture looked ordinary, just another mesa rising from the desert. But when the light hit it at the right angle, something remarkable appeared. The mesa looked like a human face. 2 eyes, a nose, a mouth. It was uncanny. The press latched onto it immediately, publishing headlines about a face on Mars. To the public, it seemed too perfect to be a coincidence. Could this be a monument? A carved statue left by an ancient people who once lived on the planet? That one image ignited decades of speculation. Books, TV specials, and entire communities of researchers sprang up around the idea that Mars held ruins, faces, pyramids, even entire cities, now buried under dust. People traced lines on satellite images connecting formations that seemed aligned, arguing that they looked too geometric to be natural. To them, Mars wasn't a desert at all, but an archaeological site. But science pushed back. Later missions in the 1990s and 2000s sent back sharper, higher-resolution photos of the face. And once the details came into focus, the illusion disappeared. What once looked like eyes and a mouth turned out to be nothing more than shadows playing across hills and ridges. The mystery collapsed into geology. The pyramids nearby, when viewed more closely, were nothing more than jagged mesas sculpted by erosion. To planetary scientists, the case was closed. Mars wasn't hiding monuments. It was hiding tricks of the light. It was hiding tricks of the light. That explanation made sense. But for many, it wasn't enough. Because the debate isn't really about one photo. It's about the bigger question. How would we even know if ruins existed on Mars? After all, Earth is covered with structures that from a distance look like natural hills or ridges until you walk among them. If a lost civilization's ruins were buried under 4 billion years of dust storms, how could we expect to spot them from orbit? The difference between natural and artificial is often clear on Earth because we have context. On Mars, we don't. A straight line carved into stone might mean erosion, or it might mean walls. From millions of miles away, it's hard to be certain, And that brings us to the darker reality. Even if civilizations once existed on Mars, time itself may have erased nearly every trace. Think about it. On Earth, our oldest human structures are only a few thousand years old, and many are already crumbling. Stone temples collapse, wooden houses rot, metal rusts. Now stretch that to millions or billions of years. On Mars, with no protection from radiation, no thick atmosphere to slow erosion, and dust storms scouring the surface non-stop, the chances of fragile ruins surviving are close to zero. Even the strongest stone would eventually be ground flat, leaving nothing recognizable behind. Radiation is another silent destroyer. Without a magnetic field, Mars's surface has been bombarded for billions of years by cosmic rays and solar particles. These high-energy blasts don't just strip away the atmosphere. They also break down organic molecules, weaken rock, and erase delicate features. What might once have been carvings or inscriptions would vanish under that constant assault, leaving behind only raw stone. And then there's the problem of perspective. We've only explored a fraction of Mars in detail. A handful of rovers crawling across tiny patches of land, a few orbiters taking images from above. Imagine trying to prove ancient civilizations existed on Earth by only photographing one desert, or by driving a single robot across a small corner of one continent. You'd probably conclude that nothing ever lived here either. The fact that we haven't seen obvious ruins doesn't necessarily prove they aren't there. It only proves we haven't looked everywhere. That's why the debate over the face on Mars and other formations never truly goes away. Science says they're illusions. Believers say they're hints we don't recognize yet. And both sides are, in a way, shaped by the same challenge: time. If civilizations did rise on Mars, they may have been erased so completely that all we're left with are faint shapes, half-ruins that our brains struggle to interpret. Too geometric to ignore, too natural to prove. Here's where the unsettling thought comes in. If Mars once had civilizations, we might never know it. The erosion of billions of years may have wiped them out so thoroughly that all traces are gone. Unlike Earth, where tectonics and biology constantly recycle the surface but also preserve fossils in layers of rock, Mars is more brutal. It preserves craters but not culture. It keeps scars of impacts but erases artifacts. A civilization could rise, fall, and vanish, leaving behind nothing but ambiguous shadows in the sand. And that's the real controversy. The question isn't whether the face on Mars is real. The question is whether we'd even recognize ruins if they existed, or whether we dismiss them, cataloging them as rocks and ridges while the true history of Mars slips past unnoticed. In the end, the fight over evidence on Mars isn't just about science versus speculation. It's about how fragile history really is. We like to think ruins are permanent, that civilizations leave indelible marks. But Mars tells a different story. A story where 4 billion years of erosion can erase even the greatest of works, until all that's left is a barren world that looks like it was always empty. And maybe that's the darkest reality of all. Not that Mars never had civilizations, but that it did, and time has already buried every last trace of them. When we picture Mars today, we see silence, a cold desert frozen in time. But some scientists and researchers argue that the planet's fall wasn't just slow erosion or gradual decline. It might have been violent, catastrophic, even apocalyptic. The idea is controversial, but there are strange clues that hint at disasters so immense they could have wiped away entire ecosystems or civilizations in a single stroke. One of the most debated pieces of evidence comes from Mars's atmosphere itself. Scientists studying the chemical composition of Martian air have found unusual levels of xenon-129, an isotope often linked on Earth to nuclear reactions. To mainstream planetary scientists, this is explained as natural exposure to cosmic radiation over billions of years. But for others, the pattern looks eerily like the fingerprint of something else: massive nuclear explosions. Some speculate that these could have been natural geological events, colossal releases of energy from within the planet. Others, more boldly, wonder if they might have been artificial, traces of technology or even war. Most of the scientific community rejects that interpretation, but the fact remains: Mars's air is strange, and the mystery is not fully solved. And nuclear anomalies aren't the only possibility. Mars shows signs of having endured colossal asteroid impacts. Its surface is covered in enormous craters, some hundreds of miles wide, reminders of events that would have shaken the entire planet. An impact of that scale doesn't just scar the land. It can vaporize oceans, strip away atmosphere, and plunge a world into centuries of freezing darkness. On Earth, the asteroid that ended the age of the dinosaurs was only about 10 kilometers wide. Mars has craters from impacts many times larger. If civilizations lived there, they would have faced devastation on a planetary scale. Then there are the volcanoes. Mars is home to Olympus Mons, the largest volcano in the solar system, towering 3 times higher than Mount Everest. An eruption from something that massive could have reshaped the climate, poisoned the air, and darkened the skies for centuries. Imagine living in fragile underground shelters or struggling farms, only to watch your planet shake itself apart in an instant. Mars wasn't just slowly dying. It was a world vulnerable to sudden, violent change. The picture that emerges is bleak. Even if civilizations or life had thrived on Mars, they would have lived under constant threat. The atmosphere was fading. The water was retreating, and hanging over it all were catastrophic events. Impacts, eruptions, perhaps even cosmic-scale disasters that could erase centuries of progress in a heartbeat. In such a world, survival wouldn't have been about building empires. It would have been about clinging to life in shrinking refuges until extinction, or until escape became the only option left. And that brings us to one of the most haunting ideas of all. What if they did escape? What if Mars, once thriving, gave rise to life or even civilizations, and when the planet became unlivable, they looked outward, to Earth? This possibility connects to a scientific theory known as panspermia. The idea is simple but powerful. Life can travel between planets carried on asteroids, comets, or fragments of rock. And Mars and Earth have been trading material for billions of years. When an asteroid strikes Mars, chunks of the planet are blasted into space. Some of those fragments drift across the void and eventually fall to Earth as meteorites. Dozens of these Martian rocks have already been discovered here, identified by their unique chemical fingerprints. We know that the traffic of stone between planets is real. The next question is whether life could survive such a journey. Surprisingly, experiments suggest it could. Microbes on Earth have been shown to endure freezing, radiation, even the vacuum of space. Encased in rock, shielded from the worst of the environment, some organisms could lie dormant for millions of years, only to awaken when conditions became favorable again. If Mars once had microbes, and it almost certainly did, some of them may have hitched a ride to Earth in exactly this way, and that's where the story turns unsettling. Because if panspermia is true, then we are Martians. Our deepest biological roots would not be here on Earth, but on a neighboring world that died long ago. Everything, forests, oceans, animals, and even human civilizations, would be the descendants of Martian life that found a second home on this planet. We would not be the first intelligent species in our solar system. We would be the continuation of something older, survivors of a timeline that began under a red sky. Think about what that means. We like to believe humanity's story begins on Earth, with our ancestors rising from the soil of Africa, building villages and slowly creating civilization. But if panspermia is correct, then Earth was not the beginning at all. It was the restart, the reboot of a story that began on another world. We would carry in our DNA the legacy of Mars not just as a neighbor, but as the true origin of life itself. And the darker twist is this: if Mars could fall, so can we. Its dry deserts and broken atmosphere are a warning of what happens when a planet loses its protection. Mars may not just be a world we study for curiosity. It may be a mirror of our own future, a reminder that civilizations, no matter how advanced, can be wiped away by forces larger than themselves. So maybe the real question isn't whether civilizations once thrived on Mars. The question is whether their legacy still lives within us, encoded in our biology, carried in our myths, hidden in the very fact that we exist at all. If that's true, then we are Martians looking back at a ruined homeland, living proof that life endures even after planets die. And that thought changes everything about who we are and where we truly come from. We like to tell ourselves that humanity's story begins here on Earth, that our roots go back to the first people who stood upright in Africa, to the first sparks of fire, to the first villages along rivers. It feels neat, complete. Earth gave us life, and from there we built everything else. But what if that isn't true? What if Earth wasn't the beginning at all, but only the next chapter in a story that started somewhere else, on a planet that now lies silent and red? For centuries, Mars has been a world of imagination, A distant point of light turned into a god of war, a fiery dot in the sky linked with myth. But science has given us a harsher truth. Mars wasn't always barren. It once had rivers, lakes, and maybe even oceans. Its skies were thicker, its climates more stable, and it carried the essential ingredients for life. If life began there, it would mean that Earth isn't unique, it's just fortunate. Fortunate enough to inherit what Mars lost. That idea turns our identity upside down. We've always believed we are the first civilization, the first species to ask questions about the universe. But what if we aren't? What if we're the descendants of something much older? Imagine life taking hold on Mars billions of years ago, building in strength and complexity as the planet slowly declined. Imagine microbes surviving in rocks blasted into space by asteroids, eventually falling to Earth, carrying the seeds of biology with them. Or imagine something even greater, a struggling Martian civilization watching its world collapse, sending fragments of itself toward Earth in a desperate bid to survive. Either way, the possibility is the same. We may be Martians in disguise. And if that's true, it reframes everything we think about our history. Our myths of lost worlds, our stories of gods who came from the sky, our obsession with the red planet, they could all be echoes of something deeper. Not fantasy, but memory. A cultural inheritance passed down through the survival of life itself. We wouldn't be the first to build cities or to dream of the stars. We would be the continuation of a story that began under a different sky, carried forward after catastrophe erased the world that came before us. But here's the darker twist. If civilizations did rise on Mars, their story ended. They were erased by time, erosion, or disaster, leaving almost nothing behind. Earth may be their second chance, but also a reminder that survival is fragile. Mars shows us what happens when a planet loses its atmosphere. When oceans vanish, when even the strongest walls crumble into dust. If our ancestry truly lies on Mars, then our entire existence is born from extinction. We are living proof that civilizations can die, but life finds a way to continue. That means we are not only heirs of Mars's past, we are also inheritors of its warning. So maybe our story doesn't begin here. Maybe it begins in another world's oceans, in valleys now dry and civilizations now forgotten. Earth then isn't our birthplace. It's our sanctuary, the place where Martian life, in whatever form it once existed, found refuge. And if that's true, then humanity is not the first spark of intelligence in this solar system. We're simply the survivors of a much longer journey, a species carrying the memory of a planet that no longer breathes. And that realization changes everything. We are not just Earthlings. We are Martians, descendants, not originals, continuations, not beginnings. Our history doesn't stretch back thousands of years, it stretches back billions. And the true story of civilization may be far older, stranger, and more fragile than we've ever dared to imagine. For all the speculation about Mars, one truth remains. We still don't know. We don't know if microbes ever swam in its lakes, if forests once stretched across its valleys, or if civilizations rose and fell under its skies. But that's exactly why every new mission matters. Each rover, each lander, each satellite is not just a tool of exploration, it's a detective, digging into the planet's past, searching for evidence that could finally answer the question we've been asking for centuries. Take the Perseverance rover, now exploring Jezero Crater. Billions of years ago, this place wasn't a wasteland, it was a lake. Rivers carried water, sediments, and nutrients into a basin where conditions may have been perfect for life to begin. On Earth, river deltas are some of the richest environments for preserving fossils. That's why NASA chose Jezero. If life ever existed on Mars, even at the microbial level, this crater is one of the best chances we have of finding its remains. Perseverance is carefully drilling into rocks, collecting samples, and sealing them into small tubes. Those tubes may one day come back to Earth, delivering the first pieces of Mars into the hands of scientists with the most advanced instruments in the world. And that's where the stakes rise. A Mars sample return mission could be the smoking gun. Imagine holding a Martian rock that shows not just chemistry but biology, patterns, or molecules that only life can produce. That single discovery would not only rewrite history books, it would rewrite our identity. We would know at last that Earth is not the only world to have carried life. And if the samples reveal something more complex, structures, cells, or even fossils, then the mystery of civilizations would no longer feel like speculation. It would feel like a possibility demanding to be explored. But even with all our machines, there are limits. Rovers move slowly. Satellites see only what's on the surface. What we need eventually are human explorers, men and women walking on Martian soil, able to notice details no robot could. An archaeologist can kneel in the dirt and recognize a pattern of stones, a strange alignment, or a faint trace of something artificial. Machines might roll past ruins without ever realizing it. Humans won't. And when we do finally step onto Mars, we won't just be astronauts. We'll be the first interplanetary archaeologists, sifting through the red dust for traces of a history that may be billions of years old. If civilizations ever lived on Mars, their ruins may not look like ours. They may be buried, eroded, or so alien in design that we struggle to recognize them. But having human eyes, hands, and intuition on the ground changes everything. The next generation of Mars exploration won't just be about geology, it will be about archaeology on a planetary scale. And that brings us to the closing reflections. Because whether Mars once had civilizations or not, the question itself reshapes how we see ourselves. If the answer is yes, if evidence shows that life once thrived on Mars, maybe even civilizations, then humanity is not the first. We are the continuation, not the beginning. Our story would stretch back far beyond Earth, into a history older than our planet itself. That means every city we've built, every story we've told, every achievement we've claimed is part of a longer legacy. We wouldn't just be Earthlings, we'd be Martians, descendants of a world that died but whose life carried on through us. But if the answer is no, if Mars is silent, lifeless, and always has been, it still carries a lesson just as important. Because Mars shows us what happens when a planet loses its protection, when atmosphere fades, when oceans dry, when a world becomes fragile and then collapses. It's a warning carved in redstone telling us how precarious habitability really is. A reminder that even thriving planets can fall silent if conditions shift. In that case, Earth is not just our home. It's a sanctuary we must fight to protect. And that is the real gift of Mars. Whether it once had civilizations or never knew them at all, it forces us to expand history beyond Earth. It makes us look at ourselves differently. We are not just a local story, we are part of a cosmic one. A story where worlds rise, worlds fall, and life, when it appears, must fight to endure. So the next time you look up at the red planet, remember, it may be silent now, but its silence speaks. It tells us that history may not have begun here, and it warns us that it might not end here either. Mars forces us to imagine more, to stretch our story beyond the boundaries of Earth. And whether we find ruins, fossils, or only dust, the search itself changes who we are, because in the end, Mars isn't just about the past. It's about our place in the universe and the fragile line between survival and silence. So maybe the question isn't just, did civilizations ever live on Mars? But what does Mars already say about us? Whether the planet once carried oceans and cities, or whether it has always been a silent desert, the red world forces us to confront history on a scale bigger than Earth. And that changes everything about how we see ourselves, our past, our future, and the fragile line between survival and extinction. If this journey into Mars's forgotten past made you think differently about our place in the universe, don't let it end here. Hit that subscribe button so you don't miss the next chapter of Hidden History. Drop a like if this made you question what we really know, and share your thoughts in the comments. Do you believe Mars once carried civilizations? Or do you think it's all just stone and shadows? Because the truth is still out there, buried in the dust. And together, we're going to keep digging. And together, we're going to keep digging.